Yo, hope you're having a good Christmas. Ho, 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 ho. In the year 2015-16 anyways. Here to help you on Solving Rational Equations Day 2 video. And so these aren't too bad as long as you follow some simple procedures and procedures there. Let's start off with one that might not be too difficult, but maybe we didn't do it in class. So number 3, so the process is, right? So step number 1, so get the, well, number 1 I guess is to choose the most complex denominator, or in other words they call that the, I think it's the least common denominator, the LCD, least common denominator. And liquid crystal display. LCD. Anyways, choose the most common, the complex denominators. In our case, well, it's just 3x minus 5 right here. The most complex over here would probably be that one. And so we need all three of them to have 3x minus 5. But Mr. Newbold, that's a whole number right there. How can you deal with a whole number? Well, we make it into a fraction, make it into a rational, 1 over 1. And you're right, it's missing the 3x minus 5. So we're going to times that whole 1 there. We're going to times that 1 with the 3x minus 5 on the bottom. And the 3x minus 5 on the top. Cool. Yeah, if it's just 1, then we have to keep it as 1 over 1. And so how do we keep it as 1 over 1? Well, we make it 3x minus 5 over itself, 3x minus 5. Because anything divided by itself is 1 back again. So that's like math manipulation and using the rules of math and not violating the rules of math, right? So we've got the same common denominator. Then you can multiply the whole thing by 3x minus 5 over 1. And so that would be, so step number 2 is get the denominator the same. Denominator the same for all of them. And then step number 3 is cross out the denominators, right? Denominator. Cross out the denominator. Let's see here. Once you've got them all the same and manipulated the top. Manipulated the top of those functions, right? So for example, we manipulated the top here by taking this 1 right here and timesing it with the 3x minus 5. Now I can cross all those out, all the bottoms, and just solve for the top. So then we'll bring down the 3x minus 5 plus 3x plus 15 equals the x plus 2. Bam. You got it here? Pounded. Have a good Christmas. Name shout, Sebastian. Woo! Hope your throat feels better. Okay, so now that we've got the top set up, we just need to solve for x now. So 3x plus 3x is 6x. A negative 5 with a positive 15. So 15 minus 5 is 10. And then we have an equals x plus 2 there. Good. And now we want to get all the x's on one side and all the numbers on the other side. So we're going to minus x to both sides like that. Cool. And then when we minus x to both sides, it goes away over to here, and that becomes a 5x. And then we're going to minus 10 to the other side to get the numbers to the opposite side there. So then we get 5x is equal to negative 10 plus 2 is a negative 8. And then just divide by 5 and divide by 5. And so we get x is equal to negative 8/5. X is equal to negative 8/5. And so that is our answer for number 3. And hopefully that helps you with the process. But I'll go ahead and do maybe a more complicated one. Let's see here. So to help you, number 4, you do need to factor it. Maybe I should mention that as rule number 2.5 or something. So to get the denominator the same, for example, rule number 4, you can pull out a p. And when you pull out a p, we're left with just a p there and then plus 2. And so cool. So that's p times p plus 2. That's p times p plus 2. And that's just missing a p. So go real quick and then come back. Oh, Mr. Newbill. So that's cool. So then we've multiplied and manipulated the top, and so now we can just cross out the bottom, and we're just left with 3 is equal to 1. None of those changed, but the 1 over here did change to a p times 1, which is just p. And then we minus 1 to the other side, and we get p is equal to 2. So number 4 actually wasn't too hard at all. Now, just to verify that, it always is good to go ahead and plug it back in and make sure it works. So 2 squared is 4, and 2 times 2 is 4, so that's 3/8 is equal to plug in a 2, plug in a 2, and then plug in a 2 over here, which is going to be a half or a fourth. So we want to know is 1/8 plus 1, sorry about that, is, let's see here, so we plugged back in there to see if it worked, so we get 3/8 is equal to 1/8 plus, and remember we plugged in 2 there, so that's 1/4. Let's make it into eighths, so we times it by 2, and we get 2/8 is what we get there. Yeah, so 2/8 plus 1/8 is 3/8, so it does work. Bada bing, bada boom. We found our answer, p equals 2. Okay, so we'll maybe look at a harder one here. That's not too bad. Remember to put negative 6 over 1, and then times the top and bottom by r minus 4. And with number 7, we've got x minus 2 looks like is a common denominator on both of those. So really just that negative 7 we need to have the same common denominator, right? Well, whenever you have a whole number by itself, you can always write it over what? You can always write it over 1. So it's going to be negative 7 over 1. Nice. So then to get a common denominator with that negative 7 over 1, we multiply both the top and bottom that denominator, which is x minus 2. So we're going to multiply that 1 with the x minus 2 to get a common denominator in the bottom, as well as with the 7. We'll multiply with the x minus 2, right? So now we do have the common denominator, x minus 2, and x minus 2. So now we just have to solve for the top. So we get x, and then we have a minus 7 that still needs to be distributed through with that minus 2. And then there's your equal sign next. Sorry for the clutter there. That 7 is being multiplied with the minus 2 there. Then we have an equal sign, and then we have a 2. So distribute the negative 7 through. We get a negative 7 times x is negative 7x. And then negative 7 times negative 2 is a positive 14. Negative times negative is a positive. 7 times 2 is 14. Equals 2. Nice. Let's see here. So then we want to get the x together. So we have this x with this negative 7x. So 1x with negative 7x is a negative 6x. Then we're going to minus 14 to both sides. Nice, like that. And then we're going to, because that goes to the other side, so we have negative 6x is equal to 2 with the negative 14 is a negative 12. And then we're going to divide by negative 6, divide by negative 6. Nice. So then the 6's go away to the other side. And so x is going to equal negative 12 over negative 6, which 12 divided by 6 is 2, and negative over negative is a positive 2. Yep, so positive 2, 12 divided by 6 is 2. Nice. So that is our answer, x equals 2. And then you need to make sure that you plug it back into the original problem. Oh my goodness. I know, right? So it turns out that when you plug it back into the original, what happens? Well, when you plug it back into the original, when you plug 2 in there, your solution x equals 2, you get 2 minus 2, which is 0. And 2 divided by 0 is undefined. And so that means that this is the extraneous solution, right? That's the extraneous. because it is a solution, but it's an extraneous solution, which means it doesn't work. So really, if we wanted to, we could say no solution if you wanted to. We could call it the extraneous solution and maybe draw a line through it, call it the extraneous solution, or say no solution, like that. But the extraneous solution is probably better. Call it the extraneous solution. And so that's, yeah, so number 7, there isn't even a solution. It's just the extraneous solution. X equals 2 is the extraneous solution. Thanks. So if this is m plus 4, and then we have m squared plus 9m plus 20, which is more complex, so we want the whole denominator to be m squared plus 9m plus 20. Probably, if you're not good at factoring, you might get some help on this worksheet by looking at what they give you. And so if they give you m plus 4, that's probably one of the factors, and it is. And the other one would be m, because m times m is m squared. 4 times what is 20? 4 times 5 is 20. There we go. So good, there we go. And then we have m plus 4 times m plus 5 again. So this side is just missing an m plus 5 to the bottom and m plus 5 to the top. So then now that we have the denominator the same all the way across, we can cancel them all out and just solve for on the top. Just solve the numerators section. So m plus 5 times 1 is just m plus 5 is equal to 2m plus 6 and then minus 1. Okay, so go ahead and take a moment. Pause me. Pause me. You solve first to see if you get it right. What's up? And then pause me. Did you just do it? Okay, now see if you get the right answer. So we're going to go ahead and minus m to the other side, so we keep the m's positive. So then we get m on this side. 6 minus 1 is 5, but we are going to bring down that 5. We are going to minus 5 to the other side. What the? Whoa, the 5's cancel. So do we get m equals 0, which is kind of crazy. And so plug that in, make sure it's not an extraneous solution. Yeah, we can get 20 there. We get 0, 0, 0, 1/4, 0, 0, 0, 0, 0, 0, 0. So we have 6/20 minus 1/20 is 5/20. And then this side we plugged in a 0, we got 1/4. And 5/20 does reduce to 1/4. Nailed it. Got it. So m does equal 0 there. Okay, so definitely bust that out and get this done right away, and also to make sure to bust out the practice test. I might do a hard one with you that you might think is hard, maybe not. But we could take a look there and maybe just do one more here after I help my buddy Dylan. Yo, what's up, Dylan? Woo! Okay, be right back. But it'll seem like you only a second, but for me and Dylan it will be longer. That's crazy. Wow, that was like 10 minutes later. I mean, for you it was just a second, but you traveled through time and for where we are now. But that was 10 minutes of helping students that were missing work and stuff. Crazy, huh? All right, so just to do one more to help you there. Let's see. This is for day 2 now, day 2. That looks like a pretty gnarly one. Let's see. So like I said, the factors are probably already there, right? Those are your 2 factors for this guy. So use that to help you, and you'll be able to do the assignment quick and easy and understand that process. Over here, looks like the most complex thing is pulling out an x, right? So divide by x, multiply by x, single factoring. So then that becomes just an x, and those x cancels out, just a 3. So we have, cool, so both of these are x times x plus 3, and they're done. You don't have to manipulate or multiply the top and bottom by anything, because they're already done. They're the most complex, or the least common denominator there. And so then we have x plus 3 is missing what? That's right, it's missing an x. So we multiply an x there, and if we do to the bottom, we have to multiply to the top. And now that the bottoms are all the same, we can just cross them out and just solve for the top. So we get 1 equals 3 times x is 3x plus 4. Solving for x right now. So we're going to go to minus 4 to both sides. So we get negative 3 is equal to 3x. And right now they're being multiplied, so we're going to divide by 3, And so then we reduce that, negative 3 over 3. So x just equals a negative 1. So there's your answer there for number 15. Woo! And if we were going to put an exclusion, we don't have to, but if we were, well, I don't know. We won't do exclusions on these ones. Extraneous is when you plug it in and it doesn't work. So it's similar to the exclusion, actually. And so, but you could plug back in that negative 1, and they should equal each other. So thanks for watching, and email me if you have any questions, or if you can't get the video to work, or just anything. Just so next you're doing the practice test, so I'll do a full video for that, and then we're doing the test after that. So thanks so much for watching, and bust this out, because it'll be due coming up real soon. Probably next time or the time after, probably next time. So get it all done. Appreciate you watching, and thank you. Have a good one. Woo!